Hello everyone, welcome back to Maths Marathon classes. This time I'll be doing 2025 JEE main binomial theorem of January shift. Binomial theorem is the first few topic and it's quite easy topic comparatively, but many of the topics are deleted from the NCERT book. You have to go beyond the NCERT book if you want to crack in JEE main. Okay, so binomial theorem I'll be doing of January shift. Okay, see the number of questions appeared from different concepts of this chapter. Binomial theorem I'll be doing of January shift JEE main 2025. Very large number of concepts you can see. We have quite a few questions. 11 questions are asked from January shift 2025 based on binomial expansion. 2 questions are there. General term, middle terms, there is no questions. Okay. Coefficient of x power k, term independent of x also, there is no question actually. There is no question on this. Can put a dash, no questions are asked. Coefficients of TR plus 1, TR plus 2 in AP, in the expansion of this are in AP, that is, and the coefficient of x power r in the expansion of 1 plus x power, there are 2 questions. Multinomial theorem, there is 1 question asked. Properties of binomial coefficients, so important, NTA's favorite topic, binomial theorem, 3 questions are asked. General, greatest term in the binomial expansion, there is no question. Finding number of integral terms in the expansion of this a power 1 by p plus b power 1 by q power n, where a and b are prime natural numbers. Okay, that is also one of the favorite topic for NTA. 1 question. Divisibility question, 1 question is there. Miscellaneous, 1 question. Mixing type question. Okay, where multi concepts are there. So altogether we have 11 questions from binomial theorem. And in 2021, when there was COVID, no, the NTA conducted JEE in 4 times, 4 shifts. During that time, in one of the shifts, no, binomial theorem appeared large number of questions. Many questions were asked from binomial theorem in one shift. Okay, and in 2023 also, the binomial theorem chapter, in that divisibility problems, there were plenty of questions on divisibility problems. Okay, so now totally we have 11 questions from January shift 2025. Okay, we'll discuss the questions one by one. The first question we have, sum of all rational terms in the expansion of this. Sum of all rational terms in the expansion of 1 plus 2 power 1 by 3 plus 3 power 1 by 2 whole to the power 6 is equal to how much? Question asked on 23rd of January, first shift, JEE main 2025 as a numerical type question. So, we have to find sum of all rational terms. This is a question based on multinomial theorem. Of course, you can see 3 terms inside the bracket. 3 terms means we call it as a trinomial. Of course, you can call it as multinomial. I'll be using the general term of this expression and find the rational terms. Okay. So, power of 2 is 1 by 3 and the power of 3 is 1 by 2. Correct? That means it is cube root of 2 and this is square root of 3. Correct? So, I have to find sum of the rational terms, sum of all rational terms in this expansion. So, first of all, I'll write the general term in this. For this expansion, we'll write the general term. So, power is 6, no? So, general term will be 6 factorial by, writing the general term. General term is given by, power is 6, no? So, 6 factorial divided by alpha factorial, right? Alpha factorial, beta factorial, gamma factorial, 1 to the power alpha, correct, into 1 to the power alpha, 2 power 1 by 3 to the power beta, 2 power 1 by 3 to the power beta, 3 power 1 by 2 to the power gamma, correct, 3 power 1 by 2 to the power gamma. Okay, otherwise I'll write in the next line, there's problem there if I write general term in the expansion is I'll write here itself, otherwise the general term is given by 6 factorial, power is 6, so 6 factorial divided by alpha factorial into beta factorial, gamma factorial, 1 to the power alpha, 2 power 1 by 3 to the power beta, 2 power 1 by 3 to the power beta, 3 power 1 by 2 to the power gamma. This is equal to 6 factorial divided by alpha factorial, beta factorial, gamma factorial. 1 to the power any number is 1, correct? So 2 to the power, all right. This is beta by 3 and 3 to the power. Powers gets multiplied. Gamma by 3 to the power gamma by 2. So this is the general term in this expansion. Now the power of 2 and power of 3, power of 2 and power of 3 both should be integer so that we get rational terms. The power of 2 is say not non-integral value, then it becomes irrational. To find rational terms, the power of 2 and power of 3 both should be integers. Of course, whole numbers I can tell. It can be 0, 1, 2, 3 like that. Power of 2, 3. Power of 2 and power of 3. Alpha, beta, gamma should satisfy some conditions. The power is 6, no? So, where alpha plus beta plus gamma should be equal to 6. Alpha plus beta plus gamma should be equal to 6. And alpha, beta, gamma all belongs to whole numbers. Alpha, beta, gamma should belong to whole numbers. Whole numbers means all natural numbers including 0. Okay. And beta should be multiple of 3. Gamma should be multiple of 2. Beta is multiple of 3. Correct. Beta should be multiple of 3. Gamma should be multiple of 2. Gamma is multiple of 2. These are the various conditions. With this much of conditions, I'll write the possible values of alpha, beta and gamma. Okay. So, we'll list out the possibilities for alpha, beta, gamma. Various cases. I'll draw the table like this. Alpha, beta, gamma. I'll make the table. Alpha can be any number, any whole number. Correct. Suppose you take alpha equal to 6. Beta and gamma both should be 0. Correct. So, to satisfy this, 6 plus 0 plus 0 is 6. So, I'll take alpha equal to 6. Beta 0, gamma 0. Correct. 0 by 3 0. 0 by 2 0. So, power of 2 and 3 both are whole numbers. Next, I'll take beta 0, if beta 6 I'll take, beta you take 6, so that alpha and gamma will be 0. That is another possibility. Next, I'll take gamma 6, alpha and beta both are zeros. Correct? Like this. 3 cases over. Still there are more cases. I can take alpha equal to 4, beta equal to 0, gamma equal to 0 by 3 0, 4 by 2, 2 by 2 is 1, correct? I'll take alpha 0, beta 0, alpha 4, beta 0, gamma 2, correct? 4 plus 2 is 6, 4 plus 0 plus 2 is 6, so that gamma is multiple of 2 are taken. Gamma is multiple of 2 means gamma can also be 4, correct? I'll take this as 2, alpha 2 and beta 0. Alpha can take any whole number. Correct. Beta should be multiple of 3. 0 is a multiple of 3. Gamma should be multiple of 2. Gamma can be either 2 or 4. Correct. 2 plus 4, 6. 4 plus 2, 6. Still there are cases. I can take beta equal to 3. Beta should be multiple of 3. Now beta is 3 if you take. Beta is 3 if you take. And gamma should be multiple of 2. So I'll take gamma equal to 2. To satisfy alpha plus beta plus gamma equal to 6, I'll take alpha equal to 1. 1 plus 3 plus 2, correct? So, 1, 2, 3, 4, 5, 6. Is there any other case you check? I can take beta should be multiple of 3, correct? I can take 3. Alpha also I can take 3. Alpha 3 I'll take. Beta 3. Gamma 0. So, the 3 plus 3 plus 0 is 6. Beta is multiple of 3. Yes, beta is multiple of 3. Gamma is multiple of 2. 0 is multiple of 2. So, these are the 7 cases I'm getting. There is no other case, okay, than this. 7 possibilities. Now, using these, I should write down the terms. I should find sum of all rational terms. For these 7 cases, I am going to get this term as a rational number. And I need to find sum of all the rational terms. That means I need to find the terms where I get rational number. Such terms you find out. Terms with rational numbers you write, then take the sum of that. That means I need to find the values of these general term for those 7 possibilities of alpha, beta, gamma. Alpha is 6, beta is 0, gamma is 0. Correct? Substitute in this general term and find out. So when you put alpha equal to 6, beta equal to 0, gamma equal to 0, write on this term. So sum of all the rational terms is required. No, right? Sum of all rational terms. Therefore, sum of all rational terms. Sum of all rational terms. Sum of all rational terms is equal to. First case, for alpha equal to 6, beta 0, gamma 0. Correct? We can write down the values, otherwise here itself I'll write. Corresponding to this. Alpha is 6 factorial divided by 0 factorial, 6 factorial, sorry. 6 factorial alpha is 6 factorial by 6 factorial 0 factorial 0 factorial. Correct? Substituting this. 2 power beta is 0 by 3. Correct? Into 2 power 0 into 3 power 0. I'll get like this. What about for this second case? Put alpha, beta, gamma values here. 6 factorial divided by 0 factorial into 6 factorial into 0 factorial. Alpha is 0. Alpha is not there here. Beta is 6. So 2 power 6 by 3. That is 2 square into 2 square into 3 power. Here 0 by 2 is 0. Next one. Alpha 0, beta 0, gamma 6. I'll get 6 factorial divided by 0 factorial into 0 factorial into 6 factorial. 2 to the power how much? Beta is 0. 0 by 3 is 0 into 3 to the power 6 by 2. 6 by 2 is 3. 3 power 3 I'll get. Next for this case, 6 factorial divided by 4 factorial into 0 factorial into 2 factorial. 2 to the power how much? Not 2 to the power, that is alpha is not there. Beta is 0. 2 to the power 0 I can write. 2 to the power 0. 3 to the power gamma is 2. 2 by 2 is 1. Correct? This is for the fourth case. And 5, 6, 7 for the fifth case. Fifth case I'll write here. Fifth case is here. 6 factorial divided by 2 factorial 0 factorial into 4 factorial. Alpha is not there to substitute. Beta is 0. 0 by 3 is 0. Gamma is 4. So this will be 2 to the power 0 into 3 to the power 4 by 2 is 2. Next one. For the sixth case I'll write here. The sixth case, 6 factorial by 1 factorial into 3 factorial into 2 factorial. Correct? 2 to the power, beta is 3. 3 by 3 is 1. 2 to the power 1. 3 to the power, gamma is 2. 2 by 2 is 1. 3 power 1. And for the last case, I am writing here 6 factorial divided by 3 factorial into 3 factorial into 0 factorial into alpha is not there to substitute here. Beta is 3. So 3 by 3 is 1. So it becomes 2 power 1 into 3 to the power. Gamma is 0. 0 by 2 is 0. So 7 cases I wrote like this. Calculate the values of this. 2 power 0 is 1, 3 power 0 is 1. 6 factorial by 6 factorial is 1. So this is 1 into 1 into 1, that is 1. Next term. Here I am getting 6 factorial by 6 factorial is 1. 2 square is 4. 4. 3 power 0 is 1. 4 into 1 is 4. 4. Next case. 6 factorial cancel. 0 factorial is 1. 2 power 0 is 1. 3 cube is 27. So sum is 20. Product is 27. Next case. 6 factorial is 720. 4 factorial is 24. 24 into 2 is 48. Correct? 7, 15 I get. 15 into 3, 45. Correct? 4, otherwise 6 into 5 into 4 factorial I can write. 4 factorial cancels. 30 by 2, 15. 2 power 0 is 1. 1 into 3, 3. 3 into 15 is 45. Next case. 1, 2, 3, 4 cases over. No? Fifth case. 6 factorial can be 6 into 5 into 4 factorial. So 4 factorial cancels. 30 by 2, 15. This is 3 square, 9. 2 power 0, 1. 1 into 9 is 9. 9 into 15. That is 135. 135. Here, 6 factorial is 720. Correct? 3 factorial is 6. 2 factorial 2. 6 into 2 is 12. 720 by 12. That is going to be 60. Correct? 60 into 2. 120 into 3. 360. Correct? 6 into 120. 6 factorial is 720. 3 factorial 6. 6 into 2 is 12. 12 ones are 12 6 are 60 into 6. 360. 6 factorial is 720. 3 factorial 6. 3 factorial 6. 6 into 6, 36. 720 by 36 is 20. 20 into 2 is 40. Correct, no? 40 I am getting. 720 by 6 into 6, 36. 20. 20 into 2 is 40. Add all these things. 5, 10, 17, 21, 22. 2 carry 6 plus 6, 12, 15, 19, 21. 2 plus 1, 3 plus 3, 6. 612 is answer. Numerical type question asked. Answer is 612. Please make a note of possibilities of alpha, beta, gamma satisfying all these conditions and learn how to write the multinomial expansion. General term of a multinomial you must be able to write. Okay. If you want, I can show the general term of a multinomial theorem where there are r terms inside the bracket. Suppose if you want to know how to write the multinomial theorem, x1 plus x2 plus x3, x1 plus x2 plus x3 dot 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 xr to the power n. Correct? In this expansion, if you want to write the general term, there are r terms inside this bracket. Okay, the power is n. The general term in this expansion is given by this. General term of this is given by n factorial divided by n1 factorial into n2 factorial into n3 factorial. Like this it goes on. Nr factorial. Okay, multiplied by x1 to the power r1, x2 to the power r2, x3 to the power r3 dot 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 xr to the power r1, n1 is right. N1. Don't write r1, n1 is power is n1. What is there here? Same thing. x1 power n1, x2 power n2, x3 power n3, xr to the power nr. Like this. This is the general term of a multinomial theorem, multinomial expansion, where n1 plus n2 plus n3 etc. nr should be equal to n. n1 plus n2 plus n3 etc. nr. Sum of all these things should be equal to n. And each of this ni should belong to whole numbers. For all I, 1 less than or equal to I less than or equal to r. Okay, all are whole numbers. Sum of this should be equal to n. This is the general term of a multinomial expansion. Okay, please learn this. And what was given is only for trinomial, correct? Previous one. Only for trinomial. I wrote in terms of alpha, beta, gamma. So learn how to write the general term of a multinomial, and they asked to find sum of the rational terms. For this to become a rational number, the power of 2 and power of 3 both should be whole number. Okay. If it is not a whole number, say if it is a fraction, then it becomes irrational. That's the concept. Okay. Hope it's clear. Question asked on 23rd January, first shift, JEE in 2025. Please make a note of this. Move on to the next one. For some n not equal to 10, let the coefficient of the 5th, 6th and 7th terms in the binomial expansion of this are in AP, arithmetic progression. AP means arithmetic progression. Then the largest coefficient in the expansion of this is to find out. First we'll find the value of n plus 4. They told n not equal 10. We have a result actually based on this. I'll write down the result and apply the result. Okay. The result to be known is if you take the expansion of 1 plus x power n, time saving result, better to learn because many times questions are asked based on this. You consider the expansion of 1 plus x power n. If we consider the expansion of 1 plus x whole to the power n, if tr plus 1 and tr plus 2 are in AP, tr plus 1, tr plus 2 are in arithmetic progression. tr plus 1, tr plus 2 are in AP. Three successive terms of this expansion are in arithmetic progression. Then what we have is n square minus n into 4r plus 1, n square minus n into 4r plus 1 plus 4r square minus 2 equal to 0. N square minus n into 4r plus 1 plus 4r square minus 2 equal to 0. This is the equation you must learn. If three successive terms of this expansion are in arithmetic progression, this is the equation satisfied. N square minus n into 4r plus 1 plus 4r square minus 2 equal to 0. Please learn it. Now, instead of n, given n plus 4. Okay. So, I'll put instead of n plus 4, I'll put capital N and write. Okay. Now, for 1 plus x power n plus 4, 1 plus x to the power n plus 4, we can write this as 1 plus x to the power capital N. Okay. Where capital N is n plus 4. Where capital N is n plus 4. Capital N is n plus 4. Okay. Now, I'll write the formula for this in terms of capital N. This, if they told that T5, T6, T7 are in AP, correct? T5, T6, T7, that means R is equal to 5, I can tell. 5th, 6th and 7th terms of this expansion are in AP. That means you compare TR plus 1, TR plus 2. So R is 5. First you write the formula for this. For this you'll write. Instead of small n, I'll write capital N for this expansion. For this expansion, what we have is, n square minus n into 4r plus 1 plus 4r square minus 2 equal to 0. They told 5th, 6th and 7th terms are in AP. That means T5, T6, T7 are in AP. Correct? So TR plus 1, TR plus 2. So R is 5. So put R is equal to 5 for this. Put R is equal to 5. What we get? N square minus n into 4 into 5. Put R is equal to 5. 4 into 5, 20. 20 plus 1, 21. 5 square is 25. 25 into 4, 100. 100 minus 2 is 98. You can factorize this easily. This is n minus 7 into n minus 14 equal to 0. This gives n equal to 7, correct? Adding minus 7 and minus 14, we get minus 21. If we multiply minus 7 and minus 14, we get 98. This gives capital N is equal to 7 or capital N is equal to 14. What is my capital N? Small n plus 4. So small n plus 4 equal to 7 or small n plus 4 is equal to 14. That means small n is equal to how much? 7 minus 4, 3. Small n is equal to 14 minus 4, 10. Small n is either 3 or 10. Okay. Small n, they told already is not equal to 10 in the question. So this value is rejected. Small n is not equal to 10. So n equal to 3 is accepted. Already mentioned that n is not equal to 10. So take n is equal to 3. If n is equal to 3, the expansion becomes what? For n is equal to 3, 1 plus x to the power n plus 4 becomes how much? 1 plus x to the power, put n is equal to 3, 3 plus 4 is 7, correct? Now they asked to find the largest coefficient in this expansion. You must know the formula for finding the largest coefficient in the expansion of 1 plus x power n. There is a formula actually. NC n by 2 if n is even. NC n minus 1 by 2 if n is odd. If you want to write the formula here, the greatest coefficient, right? Greatest coefficient. Largest coefficient is same as greatest coefficient. So greatest coefficient, there are two cases. Learn this. Greatest coefficient. If we consider the expansion of x plus y to the power n, okay? If we consider the expansion of x plus y to the power n, greatest coefficient is n by 2 if n is even. If n is even. n minus 1 by 2 if n is odd. You must know this. If n is odd. If n is odd number, then greatest coefficient is n minus 1 by 2. If n is even, greatest coefficient is n by 2. Here the power n is odd number. Correct? N is odd number. So greatest coefficient is n minus 1 divided by 2. N is 7c, 7 minus 1, 6 by 2 is 3. 7c3 calculate, that is 35. 7c3, 7 into 6 into 5 divided by 3 factorial. That simplifies to 35. Option C is the answer. Question asked on 24th of January, first shift, JEE Main 2025. So for this problem, we must know two things. One is that the three successive terms in the expansion of 1 plus x power n are in AP. If three successive terms, three consecutive terms, TR plus 1, TR plus 2 are in AP, then what is the equation satisfied? You must know. N square minus n into 4r plus 1 plus 4r square minus 2 equal to 0. And for expansion of x plus y to the power n, here of course, instead of x we have 1 and y is replaced by x. This expansion is almost same as this, where x has become 1 and y has become x. That is not a big deal, that's the same thing, okay. So if we consider the expansion of x plus y power n, greatest coefficient is n by 2 if n is even, n minus 1 by 2 if n is odd. So two results you must know to work out this problem. We can crack this question in 25 to 30 seconds, not a big deal, okay. So it's a very easy question, level 1 kind of question. Already this type of question is asked in many exams. Many of the PYQs you can see this type of question of binomial theorem, okay. Hope it's clear. So learn these two results, and one more thing I'm going to tell you, if three terms are given, three successive terms in this expansion, no, 1 plus x power n or 1 plus x power n plus whatever, in this kind of expansion, the three successive terms, TR plus 1, TR plus 2 can never be in GP. That is also one question is asked that time. So no three consecutive terms in the binomial expansion of 1 plus x power n or x plus y power n can never be in GP. Geometric progression is not possible. AP is possible, GP is not possible. Remember that. Coefficients of TR plus 1, TR plus 2 in the expansion of 1 plus x power n can never be in GP. This is the second question. Move on to the next one. Suppose A and B are the coefficients of 30th and 12th terms respectively in the binomial expansion of this. 2A equal to 5B, find the value of n. So we'll write down the 30th term, coefficient of 30th term in this. You must know one more result here. Coefficient of TR plus 1 in the expansion of 1 plus x power n is NCR. So you must know this. The coefficient of R plus 1th term. Coefficient of R plus 1th term. Coefficient of R plus 1th term in the expansion of coefficient of R plus 1th term in the expansion of 1 plus x to the power n, 1 plus x to the power n is NCR. Okay, you must know this. Coefficient of R plus 1th term, that means TR plus 1 coefficient in the expansion of 1 plus x power n is NCR. If you know this, I can write down the coefficient of 30th term in this. That is A the total. A is what? The coefficient of 30th term in this. So coefficient of 30th term in this expansion is going to be 2n minus 1 C 29. Because coefficient of R plus 1th term is NCR. See NCR, 1 less. R plus 1 means it becomes R. So A is what? According to the question. So I can write A is equal to coefficient of 30th term in this expansion. Coefficient of R plus 1th term in the expansion of 1 plus x power n is NCR. See, NCR, 1 less. R plus 1 becomes R. So 30 should become 29. So instead of n, they are given 2n minus 1. So coefficient of 30th term in the expansion of 1 plus x power 2n minus 1 is 2n minus 1 C 29. And B is equal to what? B is equal to the coefficient of 12th term in the same expansion. Coefficient of 12th term in this expansion is going to be 2n minus 1 C11. 2n minus 1 C11. If you are not able to remember, you can reduce it using general term. General term in the expansion, binomial expansion is given by TR plus 1 equal to NCR A power n minus R B power R. You can reduce it. TR plus 1 is general term, you know. NCR A power n minus R into B power R. A power n minus R into B power R. Using this we can find out. 30th term is T30. T30 means put R is equal to 29. N is replaced by 2n minus 1. 2n minus 1 C29. A is 1. B is X. We'll get coefficient of 30th term, which is 2n minus 1 C29. Just put, instead of n you put 2n minus 1. R is 29. 29 plus 1 is 30. If you want T30, you should put R is equal to 29. Correct? And get. So A and B we got. So 2A is equal to 5B. You have to find the value of M. Correct? 2A, given 2A is equal to 5B. 2A is equal to 5B. Substitute here. 2 into A is this much, no? Use NCR formula here. NCR formula, you know, n factorial by R factorial into n minus R factorial. Use that. So 2 times 2n minus 1 C29 is 2n minus 1 factorial. 2n minus 1 factorial divided by 29 factorial into 2n minus 1 minus 29 becomes 2n minus 30 factorial. Five times. B is how much? 2n minus 1 C11. This is 2n minus 1 factorial divided by 11 factorial into 2n minus 1 minus 11. 2n minus 12 factorial. Correct? Simplify this. Numerator 2n minus 1 factorial cancels. Cross multiply this. Cross multiply what we get after cancelling the numerators. 2n minus 1 factorial cancels. Cross multiply. 2 into 11 factorial. 2 into 11 factorial into 2n minus 12 factorial is equal to 5 into 29 factorial into 2n minus 30 factorial. Correct? And 29 factorial is bigger than 11 factorial. So you can write this as 29 into 28 into 27 into etc. into dot 12 into 11 factorial. So 11 factorial I can cancel from these two. And 2n minus 30 factorial I can cancel from this. This is bigger. Correct? 2n minus 12 factorial I can write 2n minus 12 into 1 does 2n minus 13, 2n minus 14 and so on. 2n minus 29 into 2n minus 30 factorial. So simplifying this, I can write this as 2 into 11 factorial into 2n minus 12 factorial could be written as 2n minus 12 into 2n minus 11. Like this we go on continue till 2n minus 29 into 2n minus 30 factorial is equal to, this part I am writing, 5 into 29 factorial could be written as 29 into 28 into 27 into, like this go on continue till 12 into 11 factorial into 2n minus 30 factorial, that you keep as it is. So what you can see from left hand side and right hand side, 2n minus 30 factorial is going to cancel, 11 factorial is going to cancel. So what is left out finally here is 2 into 2n minus 12 into 2n minus 11, like this it goes on, 2n minus 29, correct, is equal to, what we have is 5 into 29 into 28 into, like this it goes on till 12, correct, like this I get. Now what I'll do is, I'll multiply both sides by 6. So that this 5 into 6 becomes 30, 2 into 6 becomes 12. So then I can compare left hand side and right hand side. Multiply by 6 on both sides. This becomes 12 into 2n minus 12 into 2n minus 11 like this, go on, continue. This is 2n minus 29. You're multiplying by 6 on right hand side also. 5 into 6 becomes 30. 30 into 29 into 28 into and so on. Last term is 12 here. Correct? So if you cancel 12 on both sides, 12 cancels. If you equate the corresponding first factors, 2n minus 12 equal to 30. Correct? 12 is going to cancel. 12 cancels. Last factor is 11 here. So 30 into 29 into 28 into and so on to 11 I got. Here 2n minus 12, 2n minus 11, 2n minus 12, 2n minus 11 and so on 2n minus 29. If you compare the first bracket to this, 2n minus 12 equal to 30, I'll get 2n equal to 42, so n equal to 21. Suppose I compare 2n minus 11 equal to 29, I'll get 2n is equal to 40, n is equal to 20, correct? 2n minus 11 is equal to 29. Like that, if we go and compare, we'll get the value of n, correct? If you equate this, 2n minus 11, 2n minus 11 is how much? 29 if we equate. 2n is going to be equal to 40, correct? That means this factor is 1 less, correct? So 21, 20, like that it goes on. For n is equal to 21, 2 into 21 is 42. 42 minus 12 is 30. For n is equal to 21, 2 into 21 is 42. 42 minus 11 is 30. Correct? That means if you compare these, I'll get 2n minus 12 is equal to 30. 2n minus 12 is equal to 30. That means 2n is equal to 42. 2n is 42. That means n is equal to 21. N is equal to 21 I'll get. If you put n is equal to 21, you see LHS becomes equal to RHS. (42 minus 11), that is 31 I'll get. 31. The value of n is 21 we're getting, correct? No? The value of n is 21. Question asked on 24th of January, second shift, JEE Main 2025. Last factor will be 13 here, correct? Before to this is 13. That is when you put n is equal to 21 here. 2 into 21 is how much? 42. 42 minus 29 is 13. Correct? So n is equal to 21. LHS becomes equal to RHS. That is what we have. Option C is answer. Question asked on 24th of January, second shift, JEE Main 2025. Move on to the next one. (2n minus 12). I think I should have written 2n minus 13 here. Okay. Small mistake happened here. Sorry. This should be 2n minus not 11 here. 13 it is. Here it is 13, not 11. But my answer is correct. Small mistake happened here. Writing the terms which is going previous. Okay. This is 2n minus 13. 2n minus 13, 1 less. So that when you put n is equal to 21, 2 into 21 is 42. 42 minus 13 is 29. See. When you put n is equal to 21 here, 2 into 21 is 42. 42 minus 29 is 13. That is last number present there. So n equal to 21 is going to satisfy. Answer is option C. Move on to the next one. Question number 4. Alpha, beta, gamma and delta be the coefficients of x power 7, x power 5, x cube and x respectively in the expansion of this. This is a question based on the binomial expansion. What we'll do is to begin with, I'll take a root of x cube minus 1 as y. Okay. X plus y power 5, x minus y power 5. Then we'll get in terms of x, a polynomial in terms of x. I need to find the coefficients of this. X power 7, x power 5, x cube and x. Okay. Let root of x cube minus 1 be equal to y. What is given is x plus root of x cube minus 1. Correct? Whole to the power 5 plus x minus root of x cube minus 1, x minus root of x cube minus 1 to the power 5. This is equal to, I'll write this as x plus y to the power 5. For convenience, I'll take root of x cube minus 1 as y, where y is equal to root of x cube minus 1, mentioned there, where y is equal to square root of x cube minus 1. X plus y power 5 plus x minus y power 5, expand this. What do you get? This is equal to 2 times, correct? First term will add up, second term cancels, third term will add up, fourth term will cancel, like that. Because only difference is plus minus, rest everything is same, expansion. So 2 times, first term will be added up, 5c naught x power 5. Second term gets cancelled. Third term will be 5c into x cube into y square. Next, 5c3 term will cancel, 5c4 will be add up, 5c4 into x into y power 4. Get like this. Now you substitute back for y. Y is what? Root of x cube minus 1, substitute back. So 5c naught value we know. 5c naught is 1. 1 into x power 5. X power 5. 5c2 is 10. X cube keep as it is. Y square we want. Y is root of x cube minus 1. So y square is x cube minus 1. 5c4 is same as 5c1, which is 5 into x. Y power 4 will be x cube minus 1 the whole square. This is equal to 2 times x power 5 plus 10 into x cube x power 6 minus 10 into x cube. Here again expand this. What is x cube minus 1 the whole square? X cube minus 1 the whole square will be x power 6 plus 1 minus 2x cube. Expanding it using binomial theorem. Then multiply. 5x into x power 6 becomes 5x power 7. Correct? 5x into 1, 5x. 5x into minus 2x cube becomes 5 into 2, 10, minus 10 x power 4. Correct? Like this I get. I need to find coefficients of x power 7. Alpha is coefficient of x power 7. Alpha is the coefficient of x power 7. What is coefficient of x power 7? 5. 5 into 2 is 10. Correct? Alpha is 10. Beta is, according to the question, coefficient of x power 5. Beta is coefficient of x power 5. What is the coefficient of x power 5? X power 5 coefficient is 1. 1 into 2, 2. Gamma is coefficient of x cube. Gamma is coefficient of x cube. What is coefficient of x cube here? Minus 10 into 2, minus 20. Delta is the coefficient of x, correct? Delta is the coefficient of x. Coefficient of x how much? Coefficient of x here, 5. 5 into 2, that is 10. So we got alpha, beta, gamma, delta. Substitute in this. U and V is going to satisfy these equations. You have to find U plus V, correct? Substitute the values of alpha and beta in this. So the given equation becomes, alpha is 10, no? So this equation becomes 10U. Alpha is 10. Beta is 2. 10U plus 2V is equal to 18. 10U plus 2V is equal to 18. Gamma how much? Minus 20. Substitute there. Gamma is minus 20. So minus 20U plus delta we got 10. Delta is 10. 10V is equal to 20. So all the two equations. First equation I can divide by 2. Second equation I can divide by 10. First equation if you divide by 2, this becomes 5U plus V is equal to 9. Dividing by 2. Dividing by 10, what do you get? Minus U plus V is equal to 2. Subtract the two equations. Here V cancels. Correct, no? Dividing by 2 18, 5u minus 2u, sorry, minus 2u, dividing by 10, no? Minus 2u plus v is equal to 2. Subtract the two equations, correct? If you subtract, I have to change the sign. 7u, v cancels. 7u is equal to 7. So u is equal to 1. U is equal to 1, you can substitute in one of the equation. What do you get? 10 into u is 1, v is to find out. 2v is equal to 18. So 2v is equal to 18 minus 10, which is 8. So v is 4. V is 4. Or you can substitute in this minus 2u plus v equal to wherever you want. So u is 1 and v is 4. U plus v they ask, which is 5. Therefore, u plus v is equal to 1 plus 4 is equal to 5. Option A is answer. Question asked on 22nd of January, second shift, JEE Main 2025. Move on to the next one. Simple question asked on the binomial expansion, okay? And you have to solve the two equations to get the values of u and v, then find u plus v, okay? Move on to the next one. Question number 5. In the expansion of this 1 plus x power p into 1 minus x power q, coefficient of x and x square are given, 1 and minus 2 respectively. Want to find p square plus q square. So consider the expansion of 1 plus x power p into 1 minus x power q. 1 plus x to the power p into 1 minus x to the power q is equal to, expand this, 1 plus x whole power p, expand it. 1 minus x power q also expand it using binomial theorem. Expanding this, the first bracket will be pc naught plus pc1 into x plus pc2 into x square. Like this it goes on. pcp x power p, expansion of binomial. Correct? And the second one is alternate plus minus there because minus x is there, correct? So this is to be multiplied to, I'll write here, this will be qc naught minus qc1 into x plus qc2 into x square minus dot. Last term will be minus 1 to the power q into qcq into x to the power q. Like this. 1 plus x power p, 1 minus x power q we have. The coefficient of x and x square are given us. What is coefficient of x you find out from these two brackets. See, when do you get x? There are p plus 1 terms in the first expansion. There are q plus 1 terms in the second expansion. If you multiply all the terms of the first bracket to all the terms of second bracket, you get p plus 1 into q plus 1 terms. We don't have to multiply all the terms. I multiply those terms where you get x and x square only. When can you get x? By multiplying the first bracket to second bracket. 1 pc naught into this term, if you multiply to this, I'll get x. And if you multiply this term to this, I'll get x. Only in those two situations I'll get x. So pc naught into minus qc1, that'll give x. Correct? pc naught is 1. qc1 is q. You must know that. Okay? So pc naught into minus qc1, that is minus pc naught qc1. This into this, I'll get x. I'm writing coefficient of x after multiplying. pc1 into qc naught plus pc1 into qc naught is equal to, coefficient of x is how much? 1. Coefficient of x is given to be equal to 1. Correct? Equate this. Simplify this. pc naught is 1, qc naught is 1. qc1 is q and pc1 is p. So p into 1 p. Here minus 1 into q. So I'm getting p minus q equal to 1. P minus q is equal to 1. Equation 1. Okay. This is p into 1 p. This is minus 1 into q. pc naught qc naught is 1. Remember. pc1 is p. qc1 is q. Now What is coefficient of x square given? Minus 2. When can you get x square term? You see, first PC naught, if you multiply to x square, this into this will give x square. This into this will give x square. Also PC1 into x gives x square. Constant term of this multiplied to x square of the second bracket will get x square. X square term of this multiplied to constant term of this will get x square. X into x, x of the first bracket, x of second bracket, multiply, get x square. So under three situations we get x square. So I am writing coefficient of x square now. PC naught into QC2. PC naught into QC2. This into this. This into this. This into this. PC2 into QC naught. PC2 into QC naught. Correct? This into this. Also this into this. PC1 into minus QC1. So minus PC1 QC1. That is equal to how much? Minus 2 according to the question. Simplify this. PC naught is 1. QC2 is Q into Q minus 1 by 2. This is Q into Q minus 1 divided by 2. PC2 is P into P minus 1 divided by 2. QC naught is 1. PC1 is P, QC1 is Q is equal to minus 2. Multiply the entire equation by 2 and also open this bracket. What we get is Q square minus Q plus P square minus P multiply minus 2PQ is equal to minus 4. I can write the terms P square, Q square and minus 2PQ in one bracket so that I can complete the square. P square plus Q square minus 2PQ in one bracket. Minus P minus Q is minus of P plus Q. Minus of P plus Q is equal to minus 4. What is P square plus Q square minus 2PQ, which is P minus Q the whole square. Minus of P plus Q is equal to minus 4. Okay. P minus Q is 1 no, from the equation 1. So P minus Q is 1. This becomes 1 square minus of P plus Q is equal to minus 4. Correct? P minus Q is 1. 1 square 1. So 1 plus 4, 5. So P plus Q, minus of P plus Q, take that. So it becomes P plus Q. 1 plus 4, 5. So P plus Q is 5. P plus Q is equal to 5. This we call equation 2. Solve equations 1 and 2. P minus Q is 1 we have. P minus Q is equal to 1. And P plus Q is 5. Solving these two equations, add the two equations, minus Q plus Q will add up to 0. P plus P becomes 2P. 2P equal to 6. 2P equal to 6 implies P is equal to 3. Put P is equal to 3. 3 plus Q is 5. So Q is 2. P is equal to 3 and Q is equal to 2 I'll get. Correct? So that we want to find P square plus Q square. P square plus Q square. 3 square plus 2 square. 3 square is 9. 2 square is 4. 9 plus 4 is equal to 13. Option B. Simple question. Minimum 3 times this type of question is asked if you refer to PYQs of JEE Mains. Minimum 3 times this type of question is commonly found. So questions do repeat. If you are preparing for JEE Mains, please work out the synopsis first. First learn the entire chapter formula. Synopsis to be strong. Then work out all the PYQs. This much is more than enough. More than enough. 100% guarantee. Okay. So question asked on 23rd of January, second shift, JEE Main 2025. Simple question. You must know the values here. PC naught is 1. QC naught is 1. PC1 is P. QC1 is Q. In fact, NC1 is N. NC2 is N into N minus 1 by 2. All those things you must know. If you want to write here, you should know these values. NC naught is 1. NC1 is N. NC2 is equal to N into N minus 1 by 2 factorial. Must know all these things. NC3 is equal to N into N minus 1, N minus 2 divided by 3 factorial. All these things you must know. Okay. Some of the important properties of binomial coefficients. NCR plus NCR minus 1 is equal to N plus 1 CR. All these things you must know. NCR divided by NCR minus 1 you must know. All these things very important. Is equal to n minus r plus 1 divided by r. And we have NCR is equal to n by r into n minus 1 CR minus 1. Lowering of binomial. NCR is n by r into n minus 1 CR minus 1. And sum of the binomial coefficients is 2 power n. You must know all these things. All these things are very important properties. And NCR is equal to NCn minus r. NCR is same as NCn minus r. And further, sum of the binomial coefficients is equal to 0. NC0 plus NC1 plus NC2 plus etc. NCn. Sum is equal to 2 to the power n. Sum of the binomial coefficients is 2 to the power n. Sum of the odd binomial coefficients equal to sum of the even binomial coefficients. Both of them are equal to 2 to the power n minus 1. Sum of the binomial coefficients is 2 to the power n. Sum of the odd binomial coefficients equal to sum of the even binomial coefficients. Both of them are equal to 2 to the power n minus 1. Like this, it goes on. All these things you must know. And sum of the binomial coefficients with alternate plus minus is going to be 0. Sum of the binomial coefficients is 2 power n. If you take alternate plus minus in this, it is going to be equal to 0. All these things you must know. Important properties. This was a question done. Previous one. Question number 5 is over. Move on to the next one. Question number 6. Coefficients of 3 consecutive terms TR, TR plus 1 and TR plus 2 in the binomial expansion of this being GP. And P be the number of all possible values of R. Q is sum of all rational terms in this. Find P plus Q. So I'll take 3 successive terms in the expansion of this to be in GP. Actually, the 3 successive terms in the binomial expansion coefficients can never be in GP. 100% guarantee, okay? Still, I'll do this problem, okay, for time, to make you understand. So given expansion is A plus B power 12, correct? So in that TR, TR plus 1, TR plus 2 are in GP. TR, TR plus 1 and TR plus 2 are in GP. Geometric progression. Geometric progression. So TR plus 1 by TR if I not, coefficient. Coefficient of TR plus 1 by TR is going to be equal to what? N minus R plus 1 by R. TR plus 2 by TR plus 1 is what? TR plus 2 divided by TR plus 1. This is going to be equal to what? This is going to be equal to N minus R by R plus 1. N minus R by R plus 1. Okay. So they told the power n is 12. GP means what? Second term by first term is equal to third term by second term. So this equal to this. Second by first equal to third by second because the terms are in GP. So you put n is equal to 12 here. The power of the binomial is 12. So put n is equal to 12 and equate it. Put n is equal to 12 and equate 1 and 2. Correct? Put n is equal to 12 and equate 1 and 2. N is equal to 12. 12 plus 1, 13. 13 minus R divided by R. Put n is equal to 12. 12 minus R divided by R plus 1. Cross multiply. What do you get? 13 minus R into R plus 1 is equal to R into 12 minus R. This is equal to how much? 13R minus R square, correct? Plus 13 minus R. This is equal to 12R minus R square. 13R minus R is 12R minus R square plus 13 is equal to 12R minus R square. 12R cancels, minus R square cancels. What I am getting is 13 is equal to 0, which is not possible. Which is not possible. Which is not possible. So, no 3 successive terms in the expansion of this A plus B power 12 can be in GP. So, 3 successive terms in GP is not possible. So, P is number of all possible values of R. So, number of possible values of R is 0. So, P is 0. No such values of. So, P is equal to 0. That means there is no value of R for which 3 successive terms of that expansion can be in GP. So, P is 0. Okay. P is number of all possible values of R. There is no possible value of R only. So P is equal to 0. Q is sum of, first part of the problem is done. Now the second part. Q is sum of all rational terms in the binomial expansion of this. Want to find P plus Q. P is already we got 0. No three terms can be in GP for that expansion. Now find Q as sum of all rational terms. This you compare with A plus B power n and write the general term in the expansion. General term in the binomial expansion we know NCR A power n minus R B power R. This is 4th root of 3. 4th root of 3 is 3 power 1 by 4. Correct? And cube root of 4 is 4 power 1 by 3. Whole to the power 12. Correct? This is A plus B power n. We compare. A plus B whole power n. A is 3 power 1 by 4. B is 4 power 1 by 3. N is 12. Write the general term formula. TR plus 1. TR plus 1 is equal to what? NCR A power n minus R B power R. NCR A power n minus R B power R. N how much? 12. 12 CR. A is 3 power 1 by 4. 3 power 1 by 4 to the power. N is 12. 12 minus R. B is how much? 4 power 1 by 3 to the power R. Okay. N is 12. Correct. A is 3 power 1 by 4. B is 4 power 1 by 3. This is 12 CR. 3 to the power how much? 12 minus R by 4. The powers gets multiplied. 12 minus R divided by 4. 4 power R by 3. Correct? Like this I get. I want to find the rational terms. For rational terms, the power of 3 and power of 4 both should be integer, whole number. So when it happens, because the expansion has power as 12, there are 13 terms altogether. For only R equal to 0 and R equal to 12, I can get the powers to be whole number. So that I get rational terms. When you put R equal to 0, the power of 3 becomes 12 by 4, 3. And power of 4 is 0 by 3, 0. It is whole number. So it becomes rational. When you put R is equal to 12 also, I get 12 minus 12, 0. 0 by 4, 0. And here 12 by 3 is 4. Only for two values of R, I get rational terms. Correct? The power of 3 and power of 4 both should be whole number. Then only it becomes rational terms. So for R equal to 0 and R equal to 12 are the two possibilities. For R equal to 0, what is the coefficient you find out? And also for R is equal to 12, find out the coefficient. Then add those. You get sum of the rational terms in the expansion. For R is equal to 0, what I get? For R is equal to 0, I can write here. For R is equal to 0. For R is equal to 0. We get T suffix 1. Correct? Putting R is equal to 0 in this. 12C0. I'll get 12C0. R is equal to 0. I put 12 minus 0. 12. 12 by 4 is 3. So 3 cube I get. 3 cube into R equal to 0. 0 by 3, 0. 4 power 0, which is 1. 12C0 is 1. 3 cube is 27. 4 power 0 is 1. So I get 27. T1 I got. R is equal to 0 over. Next you get R is equal to 12. For R is equal to 12, what do you get? For R is equal to 12. T suffix 12 plus 1. 12 plus 1 is 13. T13 is equal to 12C12. R is equal to 12 I am putting. 12C12. 3 to the power. 12 minus 12, 0. 0 by 4, 0. 3 power 0. Here 4 to the power. R is 12. 12 by 3 is 4. 4 to the power 4. 12C12 is 1. 3 power 0 is 1. 4 power 4 is 256. So there are two rational terms. Sum of the rational terms is 27 plus 256, which is 283. This is 256. Therefore, according to the question, they told Q is sum of all rational terms. Therefore, Q is sum of the rational terms. 27 plus 256. 27 plus 256, which is equal to 283. 283. And here already we got P is equal to 0. P is 0. Q is 283, P plus Q, 0 plus 283, which is 283. Option E. Question asked on 28th of January, second shift, JEE in 2025. Please make a note of this. Finding out rational terms in this expansion. Also, there is a shortcut method to find the rational terms, okay? So, both the numbers here, 3, whatever they give numbers inside the root, no, that they should be prime number. There is a shortcut method, I'll teach you. The shortcut method is also quite important. If you consider the expansion of a power 1 by p plus b power 1 by q to the power n, where a and b are prime numbers, okay, where a and b are prime numbers. A and b are prime natural numbers. A and b are prime natural numbers, okay. P and q are some positive numbers only, okay, positive integers, of course. N should be, n is a whole number only, n is some natural number, that we know in the binomial expansion. N belongs to n, p, q, n all are natural numbers, right? P, q, n all belongs to natural numbers. Natural numbers. If you want to find number of integral terms in this expansion, number of integral terms is, shortcut method I'm going to teach you. The number of integral terms in this expansion, number of integral terms or number of rational terms, both one and the same, is given by greatest integer value of n by r, I'll write, okay, n by r. Greatest integer value of n by r, or it is greatest integer value of n by r plus 1, where r is LCM of p and q, where r is LCM of p and q. R happens to be LCM of p and q. Okay, learn this shortcut method. And when to take this also I'll tell you. You take this when r is equal to 0, when you put r is equal to 0 and r is equal to n. There are n plus 1 terms in this expansion, correct? The first term r equal to 0 and r equal to n. For those two values, for at least one of the two values, r equal to 0 and r is equal to n, out of those two, at least one value, it should be integer. That term should be integer, expansion. Then only you can take this for at least one. At least one means one or both, okay? Otherwise take this. Otherwise take this. So there are cases when to take this, when to take this. Shortcut method. I'll explain to you. For example, if you want, I'll explain for this. 2 power 1 by 3. 2 power 1 by 3 plus 5 power 1 by 4. Okay. Say you take to the power 23. There are 24 terms in this expansion. There are 24 terms. What is the general term in this expansion? TR plus 1 is given by the formula NCR, A power n minus r, B power r, correct? A power n minus r and B power r. I have taken both 2 and 5 as prime numbers. This is equal to 23CR, okay, 23 to the, 2 to the power 23 minus r, 23 minus r divided by 3. 5 to the power, this is r by 4, like this I get. 20 NCR, A power n minus r, B power r. Here the powers of 2 and 5 both should be whole number. There are 24 terms. Power is 23 means there are 24 terms, correct? So for which values of r, 24 terms are there. R can take values from 0 to 23. R equal to 0, I get first term. R equal to 23, I'll get the last term. So for which values of r, both the powers of 2 and power of 5 will be whole number. That you should take. Where r equal to 0, you take 23 by 3, that's not a whole number. 0 by 4 is 0, a whole number. 0 doesn't work. So I can tell it should be multiples of 12. 3 and 4 LCM is 12. It's not multiples of 12 actually. That is not guaranteed. So if you take R is equal to say 12, 23 minus 12, how much? 11. No, it's not possible. See, when you put R is equal to 12, this becomes whole number. This is not a whole number. R is equal to 12 doesn't work. Whereas R equal to 11 works. R equal to 11, no, for this it works. For this it doesn't work. Correct? R equal to which value is possible? R is equal to 0 is not possible. R equal to 3, this is, no, it should be multiples. It should be R by 4 and 23 minus R by 3. Both should be whole number. Such values of R I should take. 0 is not possible. 8, and then R equal to 8 is possible, check. 23 minus 8. 23 minus 8 is 15. 15 by 3 is 5. 8 by 4. R equal to 8 is possible. R is equal to 8 is possible. Next value possible is R is equal to 20. 12 doesn't work. 12 works for this, not for this. 16 works for this, not for this. 20 works for this as well as this. R equal to 20. This and this both are whole numbers. Only two values of R I am getting here. Only two values of R. Why this happens? Because when R equal to 0, this is not a whole number, this is a whole number. When you put R equal to 23, this is a whole number, this is not a whole number. For endpoints 0 and 23, both are not the whole numbers. In that case, this formula works. Greatest integral value of n by R. Number of integral terms or number of rational terms is greatest integral value of n by R. That's the formula. So only two rational terms we got, two integral terms, correct? For R is equal to 8 and 20. The powers are whole numbers means it becomes integral terms. The powers are fraction means it becomes irrational terms. So powers I made it integer or whole number so that I get rational terms. So according to this formula, see both 2 and 5 are prime numbers. A and B are prime numbers. What is the power of 2? 1 by 3. What is the power of 5? 1 by 4. LCM of 3 and 4 is 12. So I need to find greatest integer value of 23 divided by 12. Greatest integer value of number of terms is 23, correct? Greatest integer value of 23 divided by 12 plus 1. 23 by 12 is 1 point something. 1 point something, integral value is 1. 1 plus 1 is 2. So I take this one, correct? N by R plus 1. N by R plus 1. So this is a formula actually. Greatest integer value of n by R plus 1. That is going to be the answer. Not this. This. Two rational terms are there. Two rational terms. So we'll take the question on this. Seventh one, the least value of n for which number of integral terms in the expansion is 183. Least value of n need to find out for which number of terms in this expansion is 183. So both 7 and 11 are prime numbers. So given expansion is 7 to the power 1 by 3 plus 11 to the power 1 by 12. Correct? Whole to the power of n the given. Correct? 7 power 1 by 3 plus 11 power 1 by 12 whole to the power n. They told you to find the least value of n for which number of integral terms in this is 183. Number of integral terms is already given. We have the formula number of integral terms. We compare this with a power 1 by p plus b power 1 by q to the power n. A and b both are prime numbers. 7 and 11 both are prime numbers. So p is how much? 3. Q is how much? 12. R is what? LCM of P and Q. R is LCM of P and Q. LCM of 3 and 12 is going to be 12. Correct? LCM of 3 and 12 is equal to 12. R value is 12. So number of integral terms in this expansion is greatest integer value of n by R plus 1. Number of integral terms, we know the formula. Number of integral terms is greatest integer value of n by r plus 1. Greatest integer value of n by r plus 1, which is already given to be equal to how much? 183. Number of integral terms given to be equal to 183. N I had to find out. Divided by r is LCM of 3 and 12, which is 12. From this, what do you get? Greatest integer value of n by 12 is equal to 183 minus 1, 182. Greatest integer value of x is 182, means that x value should belong to the interval 182 to 183, correct? We know greatest integer value of x is, say, 5 means what? Greatest integer value of x is 5 means what? X should belong to the interval 5 to 6. Closed open interval 5 to 6. So n by 12 will what? N by 12 belongs to the interval 182 to 183. Correct? According to this. So n should belong to which interval? 182 into 12. How much is that? 182 into 12 is 2 2s are 4, 18 2s are 36. 182 into 1 is 182. 4, 8, correct? 2184. Getting 2184. So n should belong to the interval 2184. What is 183 into 12? 183 into 12 is, you should add 112 to this, correct? 366 183 6 9 11 2196. So n should belong to this 2184 to 2196. What is the minimum value, least value of n in this interval? For n belonging to this interval, we'll have total number of terms in this expansion, that to integral terms is 183. So this is a shortcut method I told. Otherwise, you can use general term expansion, tr plus 1, ncr a power n minus r b power r, and find out. So n, least value of n in this interval is 2184. That's the answer. 2184. Done. Is that clear? The least value of n is 2184. Least value of n is 2184. Hope it's clear. Learn this formula. Compare with this form. A and B both should be prime number. Then compare powers of 7 and powers of 11. 3 and 12. LCM is 12. Take greatest integer value of n by r plus 1. R is LCM of p and q. Number of terms is this 183. Number of integral terms. Greatest integer value of n by r plus 1 gives the number of integral terms in the expansion. Okay. Move on to the next one. Question asked on 29th of January, first shift, JEE in 2025. Question number 8. This is a remainder question. Problem on finding a remainder. Divisibility question I can call. Okay, on binomial theorem. 7 power 103 is divided by 23. What is the remainder obtained? You have to find out. So 7 to the power 103 consider. 7 to the power 103 is equal to, see 23 powers, 23 into 1, 23. Multiples of 23 must know. So which power of 7 if you take, you can get close to 23 you must see. Okay. So I should get a smaller number. I go on reduce it. 7 power 103 is quite large number. When divided by 23, what is the remainder? I have to find out. So 7 power 103, right? 7 power 1 into 7 power 102. And I can write this as 7 power 1 is 7. I can write this as 7 square is 49. 49 when divided by 23. 23 2s are 46. It's close. But still closer than that is 7 square. 7 cube is 343. See 7 square is 49. 49 when divided by 23. Remainder is 3. 7 cube is 343. 343 is close to 345. Correct? Because 345 is divisible by 23. So I'll take 7 cube. Okay. 345 is going to be divisible by 23. So I can express in terms of 345 there. So this is 7 cube to the power 34. Correct? So that 34 into 3 is 102. This is 7 into 7 cube is 343. 343, I'll write 345 minus 2. If I expand this using binomial theorem, all the terms contains 345 except the last term. So it is multiple of 345. All the terms are multiples of 345. Means it is also multiple of 23 because 345 is divisible by 23. You must know that. 345 is divisible by 23. 345 is divisible by 23. Okay. So 345 is divisible by 23. So I am expressing in terms of this. So the remainder obtained when divided by 23 is going to be the last term, which is minus 2 power 34. So when divided by 23, remainder obtained when divided by 23. Okay. Remainder when divided by 23, I am going to get 7 into minus 2 to the power 34, which is 7 into minus 2 power 34 is same as 2 power 34. 2 power 34 you can write 2 square into 2 power 32. 2 square is 4. 4 into 7 is 28. And 2 power 32 we can write 2 power 8 power 4. Because 2 power 8 is 256. 256 is also close to multiple of 23. 23 into 10 is 230. 23 into 11 is 253. Correct? So I can express this in terms of 2 power 8. 2 power 8 is 256. 2 power 8 is 256. 2 power 32 could be written as 2 power 8 to the power 4. This is 28 into 256 power 4. Correct? 256 is 253 plus 3 to the power 4. 253 is multiple of 23. So all the terms in this expansion will be multiples of 23. So remainder will be 0. Only last term will not be having multiple of 23. So the remainder obtained in this case will be 28 into 3 power 4. That's the remainder obtained when divided by 23 here. When divided by 23. When divided by 23, remainder obtained is going to be 3 power 4. 3 power 4 is 81. This is 23 plus 5. And 81 is 23 into 3 69. 69 plus 12. So 23 into 69 is multiple of 23. 5 into 69 is multiple of 23. 23 into 12 is multiple of 23. So what is not multiple of 23 is only these two, 5 into 12. So remainder obtained is going to be 60. 60 when divided by 23, remainder obtained is how much? 23 into 2 is 46. So remainder obtained is 14. 14 is the answer. Therefore, remainder is 14. Like this, you have to go on simplifying. This is a method of finding remainder. Many questions are asked on remainder problem, that is using divisibility concept of binomial, okay, in 2023 JEE mains. Okay. Move on to the next one. This was a question asked on 29th of January, second shift, JEE in 2025. Next, we have some questions on binomial coefficients, properties of binomial coefficients. So here summation r equal to 0 to 5 given. 11c 2r plus 1 by 2r plus 2 is given as m by n. GCD. GCD means greatest common divisor, same as highest common factor of m and n is 1. That means you should write m by n in the simplest form. Okay. So I'll be using this concept here. No, NCR is equal to n by r into n minus 1 CR minus 1. I'm using this technique. Or in other words, n plus 1 CR plus 1 if it is there, I can write this as n plus 1 by r plus 1 into 1 less 1 less. It becomes NCR. Okay. Suppose here denominator is 2r plus 2, no? So I will consider 12c 2r plus 2. What is 12c 2r plus 2 from this? 12c 2r plus 2 is going to be equal to 12 divided by 2r plus 2 into 1 less 1 less. What you get is 11c 2r plus 1. Correct? 1 less 1 less. So can you see 11c 2r plus 1 by 2r plus 2? Here also, as well as in the given question. 11c 2r plus 1 by 2r plus 2 is 1 by 12 into 12c 2r plus 2. From this, I'll simplify this. summation r is equal to 0 to 5 11c 2r plus 1 11c 2r plus 1 divided by 2r plus 2 is equal to, what is 11c 2r plus 1 by 2r plus 2? 1 by 12. 12 you take that side. 1 by 12 into, correct? From this I can write 1 by 12 into 12c 2r plus 2 is equal to 11c 2r plus 1 divided by 2r plus 2. Correct? So 11c 2r plus 1 by 2r plus 2 is 1 by 12. 1 by 12 keep outside. Summation r is equal to 0 to 5. What we have? 12c 2r plus 2. So this is equal to 1 by 12 into summation, expand, r equal to 0 to 5. That means there are 6 terms. Put r is equal to 0. I get 12c2. Put r is equal to 1. I get 12c4. Like this. Put last term r is equal to 5. I'll get 12c. 2 into 5, 10. 10 plus 2, 12. So this is sum of even binomial coefficient with 12c not missing. We know sum of even binomial coefficients is 2 power n minus 1. Correct? We know sum of even binomial coefficients. See, if it is given like this, 12c naught plus 12c2 plus 12c4 etc. 12c12. Sum of even binomial coefficients is going to be 2 to the power n minus 1. This is 2 power 11. Correct? Sum of even binomial coefficients is 2 power n minus 1. 2 power 11. So here 12c naught is missing. So you want to find this value. Correct? This much. That will be equal to how much? 12c2 plus 12c4 plus etc. 12c12 is equal to how much? 2 power 11 minus 1. Because 12c naught is 1. What is found here inside this bracket is this only. 12c naught value is 1 taken to that side. Becomes minus 1. 2 power 11 minus 1. So terms inside this bracket is 2 power 11 minus 1. 1 by 12 into 2 power 11 minus 1. 2 power 11 is 2048. 2 power 10 is 1024. 2 power 11 is 2048. 2048 minus 1. 2047 divided by 12. This is the simplest form. Further, it's not possible to simplify. That means GCD of m and n is 1. This is comparable with m by n. Further, it's not possible to simplify. Further, it's not reducible. So GCD is 1, I can tell of these two numbers. So m is 2047 and n is equal to 12. Therefore, m minus n is equal to how much? M minus n. 2047 minus 12. 2035. It's a numerical type question asked on 22nd of January, first shift, JEE Main 2025. Please learn the properties of binomial coefficients. Okay. And also, sum of even binomial coefficients is 2 power n minus 1. Sum of odd binomial coefficients also 2 power n minus 1. Sum of all binomial coefficients is 2 power n. Here what we want to find is 12c2 plus 12c4 etc. 12c12. 12c naught is missing in this. So 12c naught is 1. Shifted to that. So it becomes minus 1. 2 power 11 minus 1. It's 2 power n minus 1 where n is 12. Sum of binomial coefficients. Sum of even binomial coefficients. 2 power n minus 1. 2 power 12 minus 1. 12 is because of this. 12. N is 12. 12 minus 1, 11. 2 power 11. 2 power 11 minus 1. So 2047 by 12. In the simplest form. M is 2047. N is 12. So M minus N is 2035. Question number 9 of this. Next one. Move on to the next one. Question number 10 we have like this. Alpha is given like this. 1 plus summation r equal to 1 to 6 minus 3 power r minus 1 into 12c 2r minus 1. You have to find the distance of the point from this line. Numerical type question asked on 28th of January, first shift, JEE Main 2025. So we'll simplify alpha there. Alpha is equal to 1 plus summation r is equal to 1 to 6. There are 6 terms. Summation r is equal to 1 to 6. Minus 3 power r minus 1 could be written as, I'll write minus 3 power half into the power 2r minus 2. Because I have 2r minus 1, no? What I'll try to do is minus 3 power r minus 1 could be written as minus 3 power half, which is root of minus 3 to the power of 2r minus 2. Because minus 3 power half is root of minus 3. Minus 3 power half into 2r minus 2. Half into 2r minus 2 is r minus 1. And root of minus 3 is root of minus 1 into 3, which is I root 3. I am using the symbol iota. Root of minus 1 is I, correct? I is root of minus 1. So in terms of complex numbers, I root 3 to the power 2r minus 2, right? So summation r is equal to 1 to 6. Minus 3 power r minus 1 is I root 3 power 2r minus 2. This is I root 3 to the power of 2r minus 2. Okay. And what is left? 12c 2r minus 1, correct? 12c 2r minus 1. I'll write little below, I think. Otherwise it becomes a problem. Alpha is given to be equal to 1 plus summation r is equal to 1 to 6. Summation r is equal to 1 to 6 minus 3 power r minus 1, right? I root 3 power 2r minus 2. I root 3 to the power 2r minus 2. Okay. Into 12c 2r minus 1. 12c 2r minus 1. Like this. Now what I'll do is I'll write this as 1 plus summation r is equal to 1 to 6. Okay, this is I root 3 power 2r minus 1. I'll write first I root 3 power 2r minus 1 divided by I root 3 to the power 1, okay, into 12c 2r minus 1. This I root 3 denominator keep outside. Is equal to 1 plus 1 by I root 3 into summation r is equal to 1 to 6. What we have is I root 3 to the power 2r minus 1 into 12c 2r minus 1. And this could be written in terms of the expansion, binomial expansion, as NCR a power n minus r b power r. 1 power r is not shown because 1 to the poly number is 1, correct? This is 1 plus 1 by I root 3, okay, into, I can write this in terms of expansion of binomial. That is 1 plus I root 3 to the power 6 to the power 12, because that n is 12. Number of terms is 6 here, but 6 terms are going to cancel. Power is 12. 1 plus I root 3 power 12 minus 1 minus I root 3 power 12 divided by 2. This we can write. Correct? Because expansion of 1 plus x power n. 1 plus x power n minus 1 minus x power n. 1 plus x power n minus 1 minus x power n is equal to what? 2 times. Correct? First term is going to cancel. Second term will add up. Correct? NC1x. Next will be NC3x cube. Like this it goes on. That is what we have here. Correct? See, if you expand this, the power is odd number here. It's an odd number, odd suffix. 12C1, 12C3, I get like this. In this form I'll get. So this thing is present here. So this thing divided by 2 I wrote. This expansion is inside the bracket. So this bracket is 1 plus x power n minus 1 minus x power n by 2. That is what I wrote. And this I can relate it to the concept of omega. Omega and omega square values you must know in complex numbers. The value of omega is minus 1 plus I root 3 by 2. Correct? Value of omega is minus 1 plus I root 3 by 2. And omega square is minus 1 minus I root 3 by 2. Values of omega and omega square you must know. Okay? And here 1 plus I root 3 is minus 2 omega square. 1 plus I root 3 is minus 2 omega square. So this is equal to 1 plus 1 by I root 3 into 1 plus I root 3 is minus 2 omega square. This is minus 2 omega square to the power 12. And from this, 1 minus I root 3 is minus 2 omega. This terms inside the bracket is 1 minus I root 3. If multiply by minus 1 and cross multiply, 1 minus I root 3 is minus 2 omega. Minus 2 omega to the power 12. Whole thing is divided by 2. And this becomes minus 2 power 12, same as 2 power 12, omega power 24. Minus 2 power 12, same as 2 power 12, omega power 12. And you know omega power multiples of 3 is 1. 12 is multiple of 3, 24 is multiple of 3. Omega power 24 is 1, omega power 12 also 1. So that becomes 0 there. 1 plus 1 by I root 3 into, this is minus 2 power 12, same as 2 power 12, omega power 24, which is 1. Omega power 24 is 1. Here, minus 2 power 12, same as 2 power 12, and omega power 12 is 1. So 2 power 12 minus 2 power 12, that becomes 0 here. This is 0. 0 into this becomes 0. 0 plus 1 is 1. So answer is 1. Okay? Because you must know that omega to the power multiples of 3 is 1. Omega power multiples of 3 is 1 for all n belongs to z. Okay, like this we get. So alpha is 1. Alpha we got 1. Now you have to find distance of the point. Alpha value we got. That alpha you are going to substitute here and find the distance of the point to the line. Length of the perpendicular from the point to the line formula. So alpha is 1 you can substitute. Alpha is 1. Correct? Once we got alpha is equal to 1, that you are going to substitute in this. The point is 12 root 3, 12 comma root 3. Alpha is 1 is substitute here. The point is 12 comma root 3. Point is 12 comma root 3. And the line is given to be equal to alpha x minus root 3y plus 1 minus root 3y plus 1 equal to 0. Alpha we got 1, substitute 1 into x minus root 3y plus 1 equal to 0. The point is x1, y1. The line is ax plus by plus c equal to 0. Correct? Point we know, line we know. Distance between the point and the line is given the formula mod of a into x1 plus b into y1 plus c divided by root of a square plus b square. Distance of the point to the line is equal to mod of a is how much? 1. x1 is 12. 1 into 12. 12. A into x1 plus b into y1. B is minus root 3. Y1 is root 3. Minus root 3 into root 3 becomes minus 3. A into x1. 1 into 12. 12. Minus root 3 into root 3. 3. Minus 3. C is 1 plus 1 divided by root of a square plus b square. A is 1. 1 square 1. B is minus root 3. Minus root 3 square is 3. Correct? Simplify this. 12 minus 3 is 9. 9 plus 1 is 10. Root 4 is 2. Answer is 5. It's a numerical type question asked. So answer is 5. Question asked on 28th of January, first shift, JEE Main 2025. Hope it's clear. Linking this binomial theorem with complex numbers and also using the properties of omega. Value of omega and omega square you must remember. It's very important in complex numbers. Omega values minus 1 plus I root 3 by 2. And conjugate of omega is omega square. Minus 1 minus I root 3 by 2. Omega and omega square are the roots of the equation x square plus x plus 1 equal to 0. Cube roots of infinity and its properties are quite important. Can be asked anywhere. Linking with binomial theorem they ask. And also straight line concept is used here. Concept of straight line. Finding out the perpendicular distance of the point to the line. Point is x1, y1 and the line is ax plus by plus c equal to 0. To find the distance between the point and the line, formula is mod of ax1 plus by1 plus c by root of a square plus b square. Okay. Move on to the next one. Last question. This is okay. 11 questions were there of January shift binomial theorem JEE in 2025. This is the last question asked on. This is on 22nd of January, second shift JEE in 2025. So here also I am using the properties of the binomial coefficient. So summation r is equal to 1 to 30 r square into 30 cr the whole square by 30 cr minus 1 is given. So we can write this as summation r is equal to 1 to 30. R square you can keep as it is. First, r square you keep as it is. 30 cr the whole square is there. No, I can write it as 30 cr into 30 cr. And also I'm using NCR by NCR minus 1 here. I'm using this formula. NCR divided by NCR minus 1 is equal to what? N minus R plus 1 divided by R. I'm using this. So 30 CR by 30 CR minus 1 you can simplify. 30 CR divided by 30 CR minus 1 is going to be equal to 30 minus R plus 1 divided by R, correct? N is equal to 30. N is equal to 30. 30 minus R plus 1 by R, that is 31 minus R by R. This is 31 minus R divided by R. So I will break that. R square you keep as it is. R square. 30 CR square is 30 CR into 30 CR. 30 CR you keep as it is, 130 CR. Another 30 CR you write like this. 30 CR divided by 30 CR minus 1. Okay, like this you can write. And this part is shown here. NCR by NCR minus 1 is N minus R plus 1 by R. 30 CR by 30 CR minus 1 is 30 minus R plus 1 by R. Put N is equal to 30. So I am getting this part as 31 minus R by R. Okay, this is equal to summation R is equal to 1 to 30 R square keep others 30 CR. For this I'll be using another property of NCR. NCR is equal to, we know how to lower it, N by R into N minus 1 CR minus 1. NCR is this. So 30 CR is going to be 30 by R into 29 CR minus 1. Okay, NCR is N by R into N minus 1 CR minus 1. 30 CR by 30 CR minus 1 is 31 minus R by R. This part is simplified. This part is shown here. 31 minus R by R. 31 minus R divided by R. So using two of the important properties of NCR I simplified. One is NCR by NCR minus 1 is N minus R plus 1 by R. Another one is NCR is equal to N by R into N minus 1 CR minus 1. Both the properties are used in this problem. Okay. And here R into R is R square will cancel out. This R square will cancel with this. Correct? R into R square will cancel with R square. So I won't write that. 30 can keep outside. 30 is a constant. So number can keep outside. So 30 into summation R is equal to 1 to 30. What we have is 29 CR minus 1 into 31 minus R. Correct? Now I can multiply this. 31 into this minus multiply, summation, expand this. 30 into what we have? Multiply, summation, take summation for this as well as this. Open the bracket. Summation R is equal to 1 to 30. 31 into 29 CR minus 1. Correct? I multiplied this minus 30 into summation R is equal to 1 to 30. What we have? R into 29 CR minus 1. Correct? R into 29 CR minus 1. So much we have. I multiply this to this, multiply this to this. And this 31 you can keep outside. And this is sum of the binomial coefficients. Put R is equal to 1 to 30. What I get? 29C0 plus 29C1, 29C2 plus etc. Last term will be for R is equal to 30, 29C29. This is sum of the binomial coefficients. This is 2 power n, 2 power 29 it becomes. 30 into 31 into what is left? Summation R is equal to 1 to 30. Correct? 29 CR minus 1. Here minus 30 into summation R is equal to 1 to n, 1 to 30, R into 29 CR minus 1. Okay. This is sum of the binomial coefficients. This is 2 power 29. This is, there is one more property here for this result is that I'll show it in the next page. For this, no, summation r equal to 1 to 30, 29c r minus 1. Summation r is equal to 1 to 30, 29c r minus 1 is going to be equal to what? 29c, r is 1, 0 it becomes. Next, r is 2, it becomes 2 minus 1, 1. Like this it goes on. Last term, put r is equal to 30, I'm getting 29c, 29. This is sum of the binomial coefficients, which is 2 to the power n. Sum of the binomial coefficients is 2 power n. Okay. This is 2 power 29. This is 30 into 31 into 2 power 29. Sum of the binomial coefficients. And this part, it forms a series like this. We have a result like this. A into nc naught plus a plus d into nc1. Okay. A plus 2d into nc2. Like this it goes on. Last term is a plus nd into ncn. The coefficients of this binomial, no, the terms a plus d, a plus 2d, etc., a plus n, they form AP, arithmetic progression. Sum of this series is going to be equal to the first term coefficient plus last term coefficient into 2 power n minus 1. Learn this, okay? First term coefficient is a, and the last term coefficient is a plus nd. First term coefficient plus last term coefficient into 2 power n minus 1. Learn this as a result. And what is given here is summation r is equal to 1 to 30 r into 29c r minus 1. This series is of that type. Summation r is equal to 1 to 30. Summation r is equal to 1 to 30. What we have, r into 29c r minus 1, correct? That is what we had. R into 29c r minus 1. So this, if we expand, no, putting various values, r equal to 1 into 29c naught plus 2 into 1 into 29c naught plus 2 into 29c1. Next we put r is equal to 3, it becomes 3 into 29c2. Like this. The terms of the coefficients of this binomial are in AP. Last term is got by putting r is equal to 30. I'm going to get 30 into 29c29. Does it take this form? Correct? The terms of the coefficients of the binomial are in AP. A plus D, A plus 2D, etc. A plus ND. They form in AP here. I'm using this. Now see 1, 2, 3, etc. 30. They form in AP. Correct? 29C naught to 29C29 is there. NC naught to NCN is there. Correct? Comparable. So the sum of this series is going to be first term coefficient plus last term coefficient into 2 power n minus 1, where n is 29 here. What is first term coefficient? 1. First term coefficient is 1. Last term coefficient is 30 into 2 to the power n minus 1, that is 28. Correct? This becomes 31 into 2 power 28. 31 into 2 power 28 is sum of the series. First term coefficient plus last term coefficient into 2 power n minus 1. 30 plus 1, 31 into 2 power n minus 1. N is 29. So 29 minus 1 is 28. Learn this formula. First term coefficient plus last term coefficient into 2 power n minus 1. N minus 1 in the power, where n is 29 here. 29 minus 1, 28. So this I am going to use here. Okay. 31 into 2 power 28. This is 31 into 2 power 28. And one more 30 was there, correct? One more 30 was there. So that 30 I can keep as it is. This 30 was there. This sum we calculated, correct? This sum we calculated. This sum we calculated. 31 into 2 power 28. 31 into 2 power 28. Now you see 30 into 31 is common. 30 into 31 is common. So what remains? 2 power 28 is also common, no? 2 power 28 is also common. So what remains is 2 minus 1. 30 into 31 into 2 power 28 is common. So what remains is 2 minus 1. 2 minus 1 is 1. and this is, I want to express in terms of 2 power 29. So we can break this. This is 1. This is 1. Here I can write this is 15 into 31 into 2 into 2 power 28. 30 around 15 into 2. So they can multiply these two, becomes 2 power 29. 15 into 31 is going to be 465. Okay. 31 into 10 is 310. 310 plus 155. 465. 465 into 2 power 29. 2 into 2 power 20 is 2 power 29. 15 into 31 is 465. So we want to compare with it. Alpha into 2 power 29, correct? Alpha into 2 power 29. This is given in the question. Alpha into 2 power 29 is given. So if we compare, we'll get the value of alpha as 465. Alpha is 465. Question asked on 22nd of January, second shift, JEE Main 2025. Please make a note. So we completed all the 11 questions of binomial theorem chapter of JEE Main 2025, January shift, okay. So 3 questions were on the properties of binomial coefficients. I'll be doing the synopsis part also for JEE Mains exclusively. Please subscribe to my channel and forward to your friends, okay. This is on properties of binomial coefficients. We had the question here, question number 11, question number 10 and question number 9. All these things we had on properties of binomial coefficients, okay. And questions on middle terms, coefficient of x power k, term independent of x, all those things are not asked. This is on divisibility question we had, divisibility question. And this is on finding number of integral terms in the expansion. And this is some extra concepts I told to you. And this is on coefficient of 3 successive terms in the expansion, okay. And this is on binomial expansion. This is also on binomial expansion. This is on 3 successive terms in AP we had, correct? And this is on binomial expansion only, 3 successive terms in AP. And this is on multinomial theorem, okay? So all the questions have been covered completely of this binomial theorem chapter of January shift JEE Main 2025, and many more videos will be uploaded in the coming days. Please subscribe to my channel and forward to your friends. With this I conclude. Thank you.